This is JEE 2020 paper 2 of section 3, and which consists 24 marks and 6 questions, 4 marks for each question respectively. And there's no negative marking over here. This is a numerical value type questions. So now represent the solution right after this short break. And if you're first time on my video, then like it, please subscribe, and don't forget to hit the bell icon button to get the video first. Question number 13. An engineer is required to visit a factory for exactly 4 days. During the first 15 days of every month, it is mandatory. Okay. And the no two visits take place on consecutive days. That is here point to be noted. Then the number of all possible ways in which such visits to the factory can be made by engineer during 1 to 15 June 2021. Okay, so within this first 15 days, he has to present in the factory only for 4 days. So let's say on these 4 days, he used to present in the factory. And within these days, let x1, x2, x3, x4, and x5 are the days where he is absent. So x1 and x5 is greater or equal to 0, and x2, x3, and x4 is greater or equal to 1. So we say x2 dash is equal to that, what we call here 1 plus x2 dash is equal to x2, say 1 plus x3 dash, that we say x3, 1 plus x4 dash, you can say x4. Now substitute these values over here, where so that x1 plus x2 plus x3 plus x4 plus x5 is equal to how many days? As 4 days he is present in the factory, and total 15 days. So 15 minus 4, that is 11 days. So this sum should be 11. Now here the conditionals are that for this equation x1 and x5, these variables are greater or equal to 0, but these three variables are greater or equal to 1. So that what we call about that here x1 plus, you say x2 dash plus x3 dash plus x4 dash and plus x5, that we say 11, and here plus 1, these are all 3. So 11 minus 3, that is 8. Now that is a simple equation. These all variable become here greater or equal to 0. So here simply distribution is there. So you just make it this 8 days and check this for these intervals. So finally what we say here 8 plus, that is 3 to 5 minus 1, C 5 minus 1. That is the result finally. So number of visits will be, so required number of ways, what we say here 8 plus 4, that is 12C4. Now you can solve this also. 12C4, that is 12 into 11 into 10 into 9 upon that, what we say 1, 2, 3, 4, 3, 4, 12, and that you said 2, 5, 10. Okay, so 5 into 11, 5 into 9 into 11. Okay, so 5, 9, 45 into 11, and that we say 4, 9, and 5, and that's our answer. So final answer is 4, 9, and 5. This is your final answer. In this way you have to write. Okay, so let's go for question number 14. In a hotel, 4 rooms are available. 6 persons are to be accommodated in these 4 rooms, such a way that these rooms contains at least 1 person and at most 2 persons. So this is a very easy problem of division and distribution. It belongs to permutation combination chapter. So now 6% you just make a division here. So at least 1% is there and at most 2% is there. First take 2% in one room, another 2% in another room, and 1% in one room and 1% in one room. In this way, so division is there. So number of division for room, that is factorial 6 upon factorial 2, factorial 2, factorial 1, factorial 1, and these are repeating. So factorial 2 is there for this factorial 2, for this factorial, and for this factorial 1. What we say once again, that is factorial 2. So finally, what we conclude, that factorial 6 upon factorial 2 to the whole power 4, and that is factorial 1, factorial 1. So what we say over here, that is factorial 1 whole square. And it means here what we say, this is factorial 1. What we call, that is factorial 1 whole square. So factorial 1 nothing to do over here. So that is factorial 6 upon 2 power 4 only. Now what we say here, number of distribution. So now we will go for to arrange these in a different room. So number of ways of arranging means here now we will go for distribution. Now this distribution for 4 different rooms. So factorial 6 into factorial 2 to the whole power 4, and finally we have to multiply with factorial 4. Now this is factorial 6 720, factorial 4 that is 24, and factorial 2 that is 2, and 2 to the power 4 that is 16. Now it's solve. 4 4 16, 4 is 24, and here 6 and 720 here. That what we say 4 cancel, and then what we call 1080 is 2 fair dice, each faces with number 1 2 3 4 5 6 are rolled together. The sum of the numbers on the faces is observed. The process is repeated till the sum of their is either prime number or a perfect square. Suppose the sum turns out to be a perfect square before it turns out to be a prime number. So this is a question from probability, and that is a conditional probability. And here that is the also here, if P is the probability that the perfect square is an odd number, this shows that there is a Bayes rule. And so let's go for analyze and make the sample space for prime numbers and perfect square. So let A be the events for prime. Now for prime, what we see here, for these two die, the sum should be prime, means 1 1 should be there. Now go for with making constant 1 in first die, and for second die change the variables. So 1 2, yes, this is also 1 2, 1 3, no, 1 4 will be there, yes, 1 5 1 6, yes, 1 6 will be there, 1 7 is not there, 2 1 2 3, yes, 2 1, and now 2 2 2 3, yes, 2 3 is there, 2 4 2 5, okay, 2 6, okay, no, 3 1 3 2 3 2 is there, else, and then after 3 4, fine, 3 4 is also there, 3 4, then after 3 5 3 6, now from 4 4 1, yes, 4 1 1 4 is there, so 4 1 will be also there, 4 1 4 2 4 3, yes, 4 3 is also there, you see 3 4 is also there, so 4 3 4 5 4 4 5 4 6, no, 5 1 5 2, 5 2 is there, because 2 5 is also there, if you see. And here then after 5 4 5 3 5 4 5 5 5 6, yes, 5 6 is there, and then after you go for 6 1, okay, and 6 2 6 3 6 4, as 5 6 is there, so 6 5 is also there, and now 6 6, no, it's okay. So number of elements of A here, if you count 3 3 6 2 8 4 12 3 15 15, okay. So B, let B be the perfect square. Perfect square. For the perfect square, the terms are here. Now, once again, this one 1 3 will be there, not 1 1. So 2 2 will be there, and then after 3 1, yes, 3 1. Then after 3 2 3 4 3 5 3 6, yes, 3 1, and then 3 6 will be there, and then after what we say 4 5, yes, 4 5 is also there. So 5 4 will be also there, and here that is 1 from 6 6 3 is there, yes, fine. So the number of perfect square, for number of perfect square you say n of b is equal to 7. Now what do you have to find? You have to find that probability that odd perfect square means odd odd and perfect square, and here that is means what we recall here, that is odd perfect square probability, and this is divided, this is the numerator, and here let's say this be any other events, and perfect square here, perfect square before it turns to be prime. So what do you have to find? Perfect is under the condition that perfect square comes before before prime, and hence we say this one. So let this be S, any event S, and this be R. So what do you have to find? Probability of R intersection S upon probability of S, and that is the conditional probability you say. And here for this probability of S, you use this one Bayes rule, so that we say probability of S can be occurred like this way, but in the first chance, suppose perfect square is there, so in very first chance, that is 7 by 36, and here when another chance they get, and they won't get perfect square neither prime, so 15 plus 7 7, that is 22, and 36 minus 22, that is 14, and they won't get neither perfect square nor prime, so 14 by 36, and then they get the perfect square in another chance, so that will be 7 by 36, and in this way the process repeats, and they won't get the 14 by 36 twice, they won't get perfect square and prime, and then once again they get this one perfect square, so that we say 7 by 36, and the process repeat up to infinity until this comes. Here it is written over here. The process is repeated till the sum is either prime number or perfect square. Anyhow, come to the point, probability of R intersection S means odd perfect square. So where the odd perfect squares are there, so if you see here odd perfect square, then that is 3 6, and then is means let me mark these all points where the perfect squares are there. Here this is odd perfect square, here there is odd perfect square, so here also there is odd perfect square, and here also there is odd perfect square. So for these all odd perfect square, 4 out of this 3, all 7, so that will be 4 out of 7. So here under the condition when that is this one first that is a perfect square, so perfect square, that is it's still 7 by 36, but with this here under the condition that perfect square, here that is a odd perfect square, means 4 by 7 you have to say, and in this way another case when they won't get chance here to be a perfect square, so that will be 14 by 36, okay, and then they get the chance, and then we find perfect square 7 by 36, and then you find the odd perfect square 4 by 7, and the process repeat up to infinity. Now you have to solve this. How to solve is final required probability, that we say 7 by 36, okay, and here that is 4 by 7, 7 by 36, 4 by 7 is common over here, and that is 1 upon 1 minus 1 by, that is 14 by 1, not 1 by 14 by 36, and this is divided by, and for denominator that is once again that is 7 by 36 is common over here, and here once again that is 1 upon 1 minus 14 by 36. This is the infinity GP formula. And now if you see here, these terms are related. This term and you say this term is related. So finally, what we left over here, that is final result is this 7 by 36 is also cancelled, and that is 4 by 7. 4 by 7 is a final answer. So hence what we conclude over here, that is 4 by 7, and now this is 14p. So for this p value is 4 by 7. So you plug in this value p over here. So 14p, that is 4 by 7, and here 7 to 14 to 4 8. Now the value is 8 over here. So final answer is 8. Question number 16. Let the function f such as 0 to 1 to r be defined by this fx. And this is a very common problem in IIT and traditional type. You see fx plus f of 1 minus x. If you solve over here, then you will get 4 to the power x upon 4 to the power x plus 2 plus 4 to the power, you see 1 minus x upon 4 to the power 1 minus x plus 2. After solving this, you will get this as 4 to the power x upon 2 plus 4 to the power x. Let me write this like this way. So that is 4, and here that what we say 4 plus 2 into 4 to the power x. Now if you take 2 common over here, then that will be 2 upon, that is 2 plus 4 to the power x, and here also 4 to the power x upon 2 plus 4 to the power x, and this way you will get 1. So finally fx plus f of 1 by x is equal to 1, and you just club this first term and last term, second and second last term like this way. So f of 1 by 40 club with f of 39 by 40, and this is one pair, and another pair, that is f of 2 by 40 and plus f of 38 by 40, and so on. If you club this all, and you will get the last term. These are how many brackets will be there. As you see, f of 20 by 40 is there, so the one term will be left over there, f of up to f of 20 by 40, and here that is somehow up to the 19 terms, and minus f of 1 by 2 is ready to retaliate over here. So this term and this term will be cancelled, and how many brackets are there? If you see 1 1 1, how many brackets are there? That is plus 1. So up to 19 terms are there. So that's why how many ones? Total 19. So the answer is finally 19. That's your final answer. Question number 17. F such as r to r be differentiable functions such that f dash x is continuous, f pi equal to minus 6, and capital Fx is given this one. So if you differentiate here by using Leibniz formula, that is f dash x is equal to f of x. So finally what we consider f dash of pi, that is f of pi, and it is minus 6. And if you make a double derivative of capital Fx, then you will find f dash x. So instead of this f dash x, you can use over here, that is f double dash x cos x on multiplying this, opening this bracket, and 0 to pi, that is fx cos x dx, and that is equal to 2. Now in the first part, use by parts. So finally what we get here, this as f double dash x, integrating this one and keep it cos x as it is. So that is integration, that is f dash x, and here the limits are 0 to pi, and now minus integral of 0 to pi, that is f double dash x integral, that what we call f dash x, and here the differential of cos x, that is minus sin x, so that will be plus here, and here that is dx, and then after that is you just copy out this as it is, capital Fx, and this is cos x dx, and that what we call equal to 2. So here if you solve and use this limit, then what we say here, f dash of pi, that we use as for cos pi, that is minus 1, you can use over here for cos pi, that is minus 1, and minus, that is f dash of 0, and cos 0 degree, that is 1. So this is one of the bracket, and for another term, that is, you see, for this one sin x, so we say here for sin x, apply once again by parts over here. So that is sin x and fx 0 to pi minus integral of 0 to pi, that is differential of sin x is cos x, and integral of f dash x, that is fx, and here that is then copy out 0 to pi, that is fx cos x, and finally that is dx, that is equal to 2. So if you see over here, this term and this term related, and this is when you're substituting pi over here, this 0 and this also 0. So finally what we conclude over here, that is make it a simplified sign. So this will be the result here, f dash of pi, and f dash of pi, that was minus 6, so minus of minus, that is plus 6 over here, and that is minus f dash 0, and here the entire term is going to be 0 over here, and this is equal to, this is 0 and this is related, only 2 will be left over here. So finally what we say here, f dash of 0, that is transposing, we get 6 minus 2, that is 4, and that is nothing, it is f of 0. So f of 0 you have to find 4. Not so tough problem, easy here if you get the idea of Leibniz rule. Leibniz rule is a favorite of JE, you know. Okay, so let's go for another problem. Question number 18. F theta, that is sin theta plus cos theta whole square, sin theta minus cos theta to the whole power 4. This can be also expressed in terms of sin theta plus cos theta. So better just you can assume over here, assume sin theta plus cos theta as t, and then after you can say over here, that is f theta will become this one, that is t, for this one sin theta plus cos theta. Better you can assume this whole square as t, so no need to write t square over here, direct t you can say, and then we say that is 2 minus t whole square, whereas t is sin theta plus cos theta. Open this, you will find that is t square minus 3t plus 4. Now that is, this implies f theta will become, making a puffed square here, that is t minus 3 by 2 whole square, and that what we say, that is 7 by 4 here. So f theta is least. When it is least, f theta is least when t becomes that is 3 by 2, at t equal to 3 by 2, and the least value will become 7 by 4. Hence this implies sin theta plus cos theta, that is, you know, that is the value will be here root of this t, means root of 3 by 2, and hence this implies, we say sine of theta plus pi by 4 one can say, and that is root 3 by 2 if you divide and multiply with root 2 both sides. So you can make a single function, and in this way we can say theta plus pi by 4 will being the value is pi by 3, or that is 2 pi by 3, okay, under this condition. So what we say over here, so this is this implies that theta belongs to, means theta is here, that is pi by 12 or 5 pi by 12 is there. So if you compare with this theta belongs to this one, pi by 12 or 5 pi by 12, you can say over here like this. So this is so lambda, in when you have to compare this one, lambda 1 pi, lambda 2 pi, like this. So lambda 1 is equal to, you can say here 1 by 2, and lambda 2, that is 5 by 12. So finally, and what you have to find? You have to find this one, lambda 1 plus lambda 2, all possible values of, means lambda 1 plus lambda 2 you have to find. So what is the lambda 1, lambda 2? That is 1 by 12 plus 5 by 12. So that is 6 by 12 and hence that is 1 by 2, and that what we write 0.5. So in this way you have to mention your result 0.50, 0.50. That's your answer. Okay, that's all. Thanks for watching.